So I'm Stacey, I'm the container marketer for HPE, and I'm excited to be here today to tell you more about what we're doing in this space. As you just heard Calvin say, this is a very big interest area for our customers, and we really think that it's going to be the next big trend for enterprises. So before we dive into the deep dive of storage, I'm going to give you an overview of our HPE strategy for containers overall, the entire portfolio. Then we'll go to the strategy for storage, and eventually I'll hand it off to Dianne here, our engineer, who will give you a deep dive into our platform capabilities and also give you some demos. I point at that, don't I? Okay, so first, the HP container vision is really simple. We want to be the only major IT vendor. Sorry, I come from the storage division. It's hard not to say storage. We're the only major IT vendor to offer you end-to-end solutions with everything you need to containerize your applications and reap the benefits faster. So end-to-end solutions, I'm really serious when I say everything you need. So server, storage, networking, infrastructure, support, advice, services. And we're bundling it all together into a nice and easy to consume package. And by offering everything you need from one place, we're trying to bring you a little bit of cohesivity to this, I want to say, open source ecosystems can be very fragmented, right? And this is very difficult for enterprises, as we all learned from OpenStack. It can be very difficult to get in and get value out of these things. What happens when something goes wrong and you need to support it? Who do you call when you've got 5 different open source technologies? Well, if you've bought anything from HPE, the answer is you just call us for everything. We will support your Docker. We will support your Mesosphere licenses. A lot of the open source container vendors that we partner with will support that as well. If you've heard of Turbonomics or Aqua, for example, we do a lot of this solution bundling that combines everything together. So, and we also offer something called modernizing traditional applications, which is in partnership with Docker. That means our HPE PointNext consultants and services have a special service to help you get in and get started with containers. So pretty much everything you need. And across the portfolio, no matter what you're dealing with, we've really tried to bundle in the validation, the integration, the support and automation you need for operations. And again, one number to call for everything. And we've based our portfolio investments on 3 guiding principles that our customers tell us matter most to them. So the first one being about modernizing applications. What does that mean? Well, that's a Docker phrase for containerizing your existing applications and reaping the benefits. So existing applications, I mean traditional enterprise applications. As you all know, this comes with a few more challenges than it does to containerize a cloud-native application, right? It can be a little bit more difficult. Well, we exist to help you make that easy. The whole idea of moving applications from on-prem to cloud and back again, that's part of modernizing, right? You want to be able to dump your SQL database in a container and move that back and forth as easily as you would anything else, right? Everybody says containers are super portable, so let's make sure that your enterprise applications remain that portable. And no matter whether or not you're one of those who wants to rewrite your applications or, as Docker says, just containerize a monolith and leave it as is, we think you could go either way, and we're not wedded to either one. We just want to be the strongest application platform for you, no matter what strategy you decide. Secondly, we're going to help speed up DevOps. That's a strategy around offering the most possible automation that we can for those teams to make life easy. And third, our customers are always telling us that they want containers, but they don't really know how to operationalize them. It comes with all kinds of challenges. How do we meet tight SLAs? How do we address security challenges? How do we deploy them quickly? How do we monitor to make sure that the right people have access and the wrong people don't? And that they live exactly as long as they're supposed to, and no longer. So this is what we're going to do for across our entire portfolio, whether it's server, storage, networking, synergy, as Mark just told you about. These are the guiding principles for everything, including our persistent storage solutions. So why persistent storage? Well, if you've ever tried containerizing an existing application, you probably know that data presents some of the toughest challenges to deal with. And this is a challenge for us to make it easy for you. So we decided to offer industry-leading container integration with all of the leading container platforms, Docker, Kubernetes, and Mesosphere. We offer rich container integration, industry-leading for all of those areas, and also comprehensive REST APIs plug into automation systems so that DevOps teams can control and automate the data they want. Now, today, the demos we're going to show you happen to be from the Nimble offering, but both our 3PAR and our Nimble storage lines offer plugins to all of those three leading orchestration systems. So you can use whatever you want. Secondly, if you, again, making your applications and data applications portable, well, containers make your applications portable, but what about your data? So again, if you've got something like a SQL database, what do? Microsoft is containerizing SQL 2017 nicely for you. So the binary will move nicely between on-prem and cloud. It'll always be built the same way, and you'll always know you have the latest. But what happens to your data? And this is why we decided to get into this. And as you probably heard this morning, HPE is the only major infrastructure vendor, traditional infrastructure vendor, that is, to offer something like a true enterprise-grade multi-cloud storage service that allows you to replicate your data between on-premises and AWS and Azure. So, that together with containers, that's a nice thing. And then, for operationalizing containers, this morning you heard about InfoSight. We're bringing the full value of an enterprise-grade storage platform to your container environment and your containers. I always hear people ask, well, why should I consider buying enterprise storage for containers? I was just going to go get commodity DAS, and I thought I'd be fine with that. Yeah, you will be fine, but if you do decide that you can afford enterprise-grade storage, which you should be able to, by the way, because I hope you've been listening to everybody this morning who told you pay-as-you-go. We'll let you pay-as-you-go for everything, whether it's cloud or on-premise. We also offer things like, InfoSight, right, which delivers that transformed support and maintenance experience that you heard about, that earned Nimble the Net Promoter Score of 85 that we're so proud of, right? Our customers love us more than their iPhones and their BMWs, is what I always say, because of InfoSight, right?
And I do have to make one point. Is 85 higher than 80?
No.
Oh.
If you talk to somebody who makes all flash arrays, that would be their answer as well. If somebody claiming to have the highest net promoter score in the industry and theirs is 80. So math tells me 85 is higher than 80, last I checked.
Absolutely. Thank you, Calvin. So I hope somebody already talked about net promoter scores this morning. Also, consistent performance. Well, both 3PAR and Nimble are flash offerings. Flash is blazingly fast. And it turns out that whenever you have a problem with your environment, it's only a problem with storage about, a little less than half the time. And the rest of the time it's something else. And, only HPE with InfoSight is able to solve that entire problem for you and make sure that we monitor your performance bottlenecks underneath your container infrastructure from your storage all the way up to your VM layer. So you know exactly what's going on at all times. And finally, if you buy enterprise-class storage, you get enterprise-class data reduction, which means you're going to buy much less storage than you would if you went for a commodity DAS. So it's not always more expensive than you think it is. So now I'm going to hand it over to Dianne, one of our container experts and technical marketing engineers, who's going to give you a deep dive into why exactly our persistent storage is industry-leading.
Thank you, Stacey. So again, my name is Dianne, and I'm one of the senior technical marketing engineers for Nimble Storage. And full disclosure, Stacey's very sweet, but I'm actually the Microsoft apps person. But I happen to have my finger, because of SQL Server, in everything, whether that be cloud, so I work closely with Doug, or whether that be containers. But I'm here representing Michael Matson, who drew the long straw, I think, by getting to go to Europe.
That's a long trip.
When we talk about persistent storage for containers, we're talking about Docker. Of course, there's the Docker engine itself, right? But then we want to talk about the orchestration frameworks. And we have the Docker. In the case of Docker, we have Docker Swarm, we have Kubernetes, and we have Mesos, right, as orchestration frameworks for containerization. Just kind of going to go through this because a lot of this is a repetition of what Stacey said. And when it comes to plugging into these orchestration frameworks, in the Docker side, we have Windows and we have Linux volume plugins. On the Kubernetes side, we have the Flex Volume driver that's plugging into the Flex Volume plugin. And then for the Marathon scheduler, we have the Docker Volume driver isolator. Okay. And when you look at across all three of these orchestration frameworks, the least common denominator here is really the Docker Volume API. So as long as we can plug into the Docker Volume API, we can provision and manage storage for all of the orchestration frameworks. It looks a little different when it comes to Unix and Windows. On the Unix side of the house, we're interfacing with a Unix socket or a Linux socket, right? On the Windows side of the house, we're actually interfacing with a daemon that's listening on a secure port. And as Stacey said, we have a volume plugin for Nimble storage as well as 3PAR. But we also, I think, have one for Store Virtual, right?
I think so, yeah.
So
That's right.
So a little bit about the Docker Volume API. This is a lot of text. It's actually the output of some of the driver options that we have for our Linux, our Docker Volume plugin for Linux. And all of these keywords are really specific to the third-party driver that you're using in your orchestration framework. But I'm going to consolidate the messaging of all those keywords in a kind of more hierarchical view, right? And basically say that we offer solutions. Not only do we offer container integration, but we offer data services like automation. Again, we interface with all three of the major orchestration frameworks. We have a Linux and a Windows plugin, right? I think as of this point, we're still the only ones who have a Linux and Windows plugin for containers. Okay. We also our platforms offer fully featured REST APIs. So if you want to create custom workflows using whichever one of your automation frameworks that you like for example, Puppet, you can. Robust platform, highly performant, highly available, measured uptime. Stacey kind of went over this already. One of the things she didn't really touch upon were performance policies. Again, we're focusing on Nimble storage here, but we have performance policies that allow you to very quickly provision storage for applications. And those things, the things that the performance policies govern are things like block size for the volumes, whether or not we have all flash or hybrid storage backing your volumes. We're able to assign QoS limits, and those can be globally scoped or at the volume level itself. We're able to offer granular encryption for all of the volumes. And some of these are platform generic, meaning we offer it for everything. But many of the things that we're kind of going through in this table are directly provisionable using our Docker Volume plugin, right? Data protection and storage efficiency. We're able to protect volumes by applying protection templates. And of course, we offer data reduction with industry-leading thin provisioning and deduplication and compression. And Stacey's already talked about the application data portability. The technical side of that means we can do that with either our zero-copy clones. We're able to also use volume import options with our Docker Volume driver, which allows us to modernize the applications, right? Taking them out of whatever infrastructure they're in and putting them in a container by using a volume import option. And plan for future release, and this is really important. We are soon to have integration with Nimble Cloud Volumes. So that will make this a truly unified kind of platform for Docker operations. Okay. So for the demos today, what I'm going to be leveraging is Docker. I'm going to be using the Docker engine. And on the back end, what I'm going to be using is Docker Compose to kind of bring up and take down containers. It's kind of funny because we're talking about persistent storage for databases, which is really important. And as a SQL girl, I can appreciate that. But for the purposes of the demos today, I'm actually going to be bringing stuff up and tearing it down. So it's going to have much more of an ephemeral flow, right? But the idea here is that we're able to bring up, to create persistent storage. Here I'm taking a look at a sample Docker composed YAML. Right now we're going to create a new volume. So the first thing we're going to do under the volume specification is give the Docker volume name. And in the case of a new volume creation where we're not using any import options or any clone options, the key is going to be the name, the base name on the array as well. Okay. We're going to then call the Nimble driver. And here are our options. You can see I've specified a size, and this is just a sample, a default performance policy. In the case of the default performance policy, that's a 4K performance policy. It's very commonly used for just general file services or virtual storage. I've also got some QoS options. In this particular case, I'm limiting IOPS and throughput. And I've gone ahead and enabled encryption on the volume. And obviously, after this would be a services specification, at which point I could do a Docker compose up and boom, I have a container with brand new volumes, right? Again, these are our Nimble storage driver options. Okay, that's unique to us, that we call with the driver Nimble this line right here. So now, moving on to the demos. In case you need to repoint the camera, I'm going to sit so I can drive. You need help plugging in? Talk amongst yourselves while we get the technology going. Yeah. Calvin, what's our time check? This is going to be a long day if we can't get that resolution a little different.
You can change it. That's what happens. Go to the Apple system preferences.
Let's go here to the displays. All right, let's see.
And then do best for NFP.
Okay, that's better. That's better.
Spell it out system.
It's plenty of time. It's like half an hour. It takes less, that's fine.
Cool. Perfect. Okay, nope, that makes it worse. Let me increase it. It looks kind of blurry, and I hate it for the, can everybody kind of read that okay?
It's pretty blurry.
Yeah, it's pretty blurry.
Go back to the system preferences. Go back to scaled.
Scale.
It's 720.
Interesting. All right,
Is that better?
let me see. Actually, that is better. It's still not the best, but it's better. Okay. Let me bring this up. All right, so actually, we're going to have to play a little bit with this file real quick so it fits in the screen. All right, that's better. That allows me to go over this. So the first thing I'm going to kind of go over here is, and I'm sorry to do this to you, but I noticed that half of this is out of the page, so that's better. Okay. So let's talk about the Docker Volume plugins themselves that we offer and how you get them going on your Docker host. Like I said, we have two flavors. We got Windows, that supports obviously Windows containers and Windows Server 2016 and later. And we also have one for Linux. Okay. When it comes to the Linux Docker Volume plugin, that's actually installed as part of the Nimble Linux toolkit, which includes other tools like, for example, the Nimble Connection Manager that simplifies the connectivity to our Nimble storage volumes. It also comes with an Oracle cloning tool for those of you who like Oracle that allows you to manage the lifecycle and cloning of Oracle databases, right? But more importantly, since that's what we're focusing on here, it also comes with the Docker Volume plugin for Linux. On the Windows side of the house right now, it's a separate install. It's not part of the Windows toolkit. But it's a very simple install. It's actually an extractor. You download a zip file, you extract it to a location, you register a service with a batch file, and off you go. You're ready to start configuring the Docker driver itself. Okay. Both of the volume plugins have a Docker driver config file, and that configuration file allows you to set the default behavior of the Docker volume driver on the hosts, as well as any overrides. And what I have right now pulled up is the Docker driver configuration file that you would see on one of the Linux hosts. Okay. These are basically the defaults that you can set. That's how the driver would behave for any new creation or any clone options whenever it's invoked as part of container creation, right? And then the second part of this is overrides. The difference between defaults and overrides is, well, the defaults are just defaults. However, if I'm working at the Docker command line, if I do a Docker run and I specify a specific option that is different from the default, I can override it from the API level, right? However, if a setting is set at this override section, which is this second section here, doesn't matter what I type in that command line, it's not getting overridden. All right. So these are two different ways that you can play with the behavior of the Docker driver. We have the same thing for Windows, and they're both aptly named the same thing, docker-driver.conf. Okay. One of the things to note on this file in particular is this section right here, destroy when removed. During the demos that are coming up, you're going to see the different behavior of this option. On my Linux Docker host, I actually have this set to true, which means when I remove a volume from Docker, I'm also destroying it on the array. On the Windows machine, however, I have it set, on the Windows Docker host, I have it set to false, which means when I remove the volume from Docker, on the array, I set it offline. And I'll show you what that looks like. Okay. Okay. That's about as good as we're going to get, so let's go ahead and get started. I'm going to first start by going over the demo environment that I have. I have a SQL Server instance that's running on a Windows virtual machine. And that SQL Server instance has many databases. We'll call this our production environment. And for the demos, we're going to be manipulating mostly this virtual database 1 and the virtual database 2. Okay. If we take a look at the array, right now, I have the databases. The volumes that back the databases are stored in separate folders, and that's not just for organizational purposes, but as you'll see, it's for allowing us to set global performance or limits on the volumes that are within each one of these folders. Here's the user and transaction log database volumes that are backing that virtual database 1, and if we go into this DevOps folder, you'll see the user database and transaction log volumes that are backing that virtual database 2. And again, if you'll recall from the previous screen for SQL Server Management Studio, those are the two databases that we're going to be playing around with. Like I said, folders allow you to do more than just organize. They allow you to set limits, right? In this particular case, I've set a usage limit of 100 gigs, which means all of the volumes in that folder can't exceed 100 gigs total, right? And I've also set some QoS limits as well, in both IOPS and throughput. If we go to the production folder, which is what's housing VirtDB1 or Virtual Database 1, you'll notice that there's no limits in either usage or in performance. Okay. These are defaults, by the way. If I set a limit on a volume itself, it is overridden, and we're going to see that in the demo. So I'm going to switch right now to our Linux host. Okay. And like I said, I'm going to be using Docker Compose. And I've already gone ahead and pre-created our projects. So the first thing I'm going to do is I'm going to show off basically the options to create volumes on the array as part of container creation. So this should look a little bit familiar because it's what we went over on the PowerPoint. This is the volume specification in a YAML file. What I just highlighted there are the Nimble driver options. We're going to be making use of the folder option, which basically says when you create this volume, put it in the DevOps folder, As you saw, that DevOps folder had its own QoS limits, but I'm going to override them by setting options here. And these are less than the ones that are on the folder. I'm going to be making use of the Microsoft SQL Server Linux image for 2017. I'm going to be listening on ports 1403 for this container. And then that last part of the specification there basically says I'm going to attach those volumes to the container, after which point I will attach once I bring the container up, I'll go ahead and create a SQL database, right? So now we're going to do a Docker compose up. The -d flag basically says create a detached container, which means the terminal releases back to me, and I'm able to do whatever else I need to do on the terminal. If I do a Docker volume ls at this point, or a list, I can see that 2 volumes have been created. And I can also list the running containers on this host, and we've got a running SQL Server database container ready to go. If we switch back to the array, we'll notice we have our 2 volumes that were created. Some of the options that were in that Docker compose file were encryption true. You'll notice these volumes are encrypted. And if we take a look at the performance, the limits here are different than the folder limits, right? So these volumes are actually created with a lower IOPS and throughput limit. And this is a fully functioning SQL Server instance at this point, right? So if we switch over to SQL Server Management Studio, I can connect to it. If you'll recall, the port that we set was 1403. And right now there are no databases in here, but I can easily create a database. And I happen to have all of this script right now in SQL Server Management Studio in separate queries. Here's a query that's going to create the database. I have to make sure that it's connected to the instance. Very quickly, it's going to execute. And while it's executing, I believe in a couple seconds, I'm going to switch back to the array. Let's see. Now we're going to create a stored procedure that's going to allow us to populate data. Everybody can see everything?
Dianne,
Mm-hmm.
what keeps track of the one volume to container relationship for security? For Chris on Twitter.
Can you be more specific?
He just said, what keeps track of LUN/volume to container relationship for security, not LUN to host, especially when container moves hosts.
When the container moves the host, what keeps track of the LUN volume security? So this is an interesting discussion because for example, if you're talking about like a Docker Swarm instance, where not even then would that. Could you ask them to clarify the question? Because even like in a Docker Swarm type of scenario, right? Typically what you have is you've set up your container so that it's able to move between the different Docker hosts. And essentially what we have is a way of fencing between the Docker hosts to see who's owning that volume at that moment in time. But security, just to kind of go back and talk about security, if we go back to the Docker configuration file, one of the things that we can do is we can force Docker hosts to only be able to go to a certain folder or see a certain folder, manipulate a certain folder. That's part of that Docker configuration. I'll wait for a little bit more clarification, but for now I'm going to continue.
I'll let you know. Thank you.
Okay. And right now what we're doing is we're populating that database with data. And of course, you can populate the database with data in many ways in this fashion. You could do a backup and a restore. In this case, I'm leveraging that stored procedure that I created. I'm going to switch back to the array, and I'm going to switch to real-time performance statistics for this volume. And the reason why I wanted to show this is because you can see our QoS values are being honored. The folder QoS values have an IOPS limit of 1,000 IOPS. And in particular, we hard-coded, that's why you have an orange line going across. On the volume itself, however, we hard-coded a lower QoS settings. And right now it's capped at 500 IOPS, which is what we set for this core little volume. Okay. And it looks like our stored procedure is finished. So if we come back over here, here's our database. And it has database tables, and each table is populated with data. So now the next thing that we're going to do, and I know I said persistent storage, because from here you could do a whole host of other manipulations, like you could edit that database further, you could clone it into more containers, but I'm actually going to do those demos using something else. But right now what I'm going to do is I'm going to do a little bit of cleanup so I can show you some of the Docker volume driver configuration behaviors. So this is where I said, even though this is persistent storage, since I'm pretty much deleting everything as I create it, it's not so persistent. But you can imagine that it can stay around for as long as you want it to. Okay? Since I am using Docker Compose, I'm going to do a Docker Compose -v. And the -v flag tells it, remove the volumes from Docker. And because of the way we have the Docker driver configured, you remember with Linux, I said when we remove the volumes from Docker, we're also going to delete them from the array. Let me pause this real quick. Okay, because that moves us on to the second one. I want to kind of go back a little bit here. There we go. Here's where we removed it. So now when we go into this folder, you'll notice that those cloned volumes, sorry, not those cloned volumes, that those created volumes are gone. And that's because of the way we configured the Docker driver behavior with that dockerdriver.com. So again, we told it, when you remove the volumes from Docker, also delete them from the array.
So Diane, I think I can bring Chris's question a bit more to you.
Mm-hmm.
In a scenario where I've started up a container with a persistent volume attached to it, I've then for some reason I've shut down that container, and I'm going to start again.
Uh-huh.
What controls, and I may well be saying that container instance on another host, what controls the relationship between that container instance and essentially the LUN sitting on my Nimble behind it that holds the persistent data?
Okay.
What controls and secures that access?
So a couple things. The most important one is going to be that configuration file. So for example, you're not going to be able to go to a host that can't see that DevOps folder and bring up that volume. Okay. So we're able to forcefully pin Docker hosts to certain environments, right?
So the DevOps folder was inside the Nimble.
Yep, that was in the Nimble array.
And that was a security control back to a host, but not to a container instance.
But not to the container instance itself. It's set at the host level.
So there isn't an explicit security.
Not that I know. We would have to ask Michael if there's something that he knows. But from my understanding, no. The security is at the host level, not between the containers. Right. So if as a host, I have access to a certain folder, then I'm able to manipulate the volumes in that folder. Right?
Yeah, which mirrors where Docker comes from the hyperscalers, where you would have 100 hosts running 10,000 containers to run a single application, and that would be a security domain. But it doesn't match well to what enterprise customers do of having a dozen container hosts running 15 different applications, 15 different security domains sitting on those same dozen hosts. Mm-hmm. But that's not so much a failing of the integration with Nimble as it is Docker's architecture.
I was about to say, so now what you just said is Docker's architecture, which they're trying to, so if you look at Docker, for example, a Docker Swarm offering, you have the universal control plane, you have everything. So they're trying to build all of that into that application stack itself, right? The Docker engine itself. What we have is essentially a driver that allows you to provision storage that is leveraged by the engine or by the orchestration framework to provision and manage storage, persistent storage in particular, right? It's kind of like, to put it the question in a different way, it's kind of like saying I've created a SQL database and I've attached LUNs those LUNs to a machine. Now I've destroyed my SQL database, I've detached those LUNs from machine one. What's to say that I can't take those LUNs and attach them to another Windows machine, right? So it's kind of the same parallel here. On the flip side, what's securing the database is SQL itself, right? So that puts it kind of more into a different kind of discussion. So now, that was a demo that we just went through.
Is this code just GitHub available?
Absolutely it is. Our Docker plugins are Docker certified, and they're all available off of the Docker. They're all available from GitHub and the Docker site, so you can download them all. All right, and that's both Windows and Linux. We have Docker certified plugins for both. Okay, So now I mentioned we just did this in Linux, and this was just kind of a quick show and tell of using create options. Now I'm going to show you how we can do this in Windows, right? So in this particular case, I'm going to focus on this virtual database 1 that we have running in our SQL, in our production environment, our SQL Server instance. And what I'm going to do is I'm going to take that virtual database 1 and I'm going to create a clone of it. And I'm going to take those clone volumes, import them into Docker, create a container, and attach that database to a container. Since we're using Docker Compose, and I've already created my projects, I'm going to really quickly go and examine the Docker Compose YAML for that workflow. Again, taking a look at the Docker Compose file, under the volume section, the volume specification, you'll see where we call our driver and the driver options that we're going to be using to complete this workflow. In particular, we're going to be using import vol as clone. And what that's going to do, to the right of import vol as clone is the name of the volume as it appears on the Nimble storage array. And what we're going to do is we're going to create clones of those volumes. We're leveraging the the Microsoft Windows Developer Container image. We're going to create clones of those volumes, import them into Docker, attach them to the container, and then we're automatically going to mount the database. So Docker Compose up. First thing we're going to do is create the clones, and then we're going to create the container. And that's part of course, Docker Compose. And while that's, excuse me, didn't mean to move this. While that is running, we're going to switch really quickly to the array. And you can see that pretty instantly, our clones are created. An interesting thing to note about the clones, by the way, in the space usage, you see that 0 bytes. Again, we're leveraging our 0 copy clones on the back end, so these aren't full copies. And even though in my demo environment, I have relatively small data sets, right? That cloning process is the same, whether it's 2 terabytes, 20 terabytes. I actually have a demo video where I clone a 5 terabyte database in seconds. And that's, again, because of the way we do cloning on the array. Our container creation is complete. If I do a Docker volume ls, I see my 2 volumes on my Windows Docker host. If I do a Docker ps, which is going to list the running containers on this host, I see that my container is up and running. And again, this is a fully functional database instance. I'm connecting here to an IP address, and that's because I'm making use of the Windows Hyper-V network driver, which allows me to assign IP addresses rather than using NAT, where I translate that to a port. And that's because I wanted to play around with that functionality. And here we compare the 2 databases. You'll see that they're exact duplicates. So now we have a cloned, in pretty much seconds, we've cloned this production database. We've put it into its own fully functional instance. That could be a reporting instance. It could be a development and test instance. It could be a staging instance for an upgrade. It doesn't matter. The uses are numerous. And these are not linked clones, meaning it's not dependent on the source. Right here, what I'm going to do is I'm going to use a script to essentially create a table within the container database. Choose the right database, hit execute. And if we refresh this view, we'll notice that now I have an extra table in this database, even though I started from a production data set. So I can manipulate this production data set. I can create data to it, add data to it. I could also delete data from it. So for example, if I only needed a schema for my development purposes, I'm able to just provide a schema in a container. If I needed to sanitize data because there's identifying data and I don't need my developers to see that, I'm able to process that as well. And then I'm able to take this new data set that I have in this container, right? And I'm able to use yet another one of our options, which is the clone of option, to take this data set and multiply it as many times as I need to for the purposes of development or whatever it is that I happen to be doing in the enterprise. I'm going to change directories to my other project, and we're going to examine that Docker file. And it's going to look a little bit different. It's going to be a little longer. Okay. And you can see here again, under the volume specification, we have all of our driver options for Nimble. And what I'm doing is I'm using in particular the clone of option, which is basically saying to the right of clone of, that name that you see there, when I do a Docker volume ls, that's the name of the volume in Docker that I'm cloning. And I'm essentially cloning my user database volume and my transaction log volumes that back that container database 3 separate times, so 6 new volumes. And then I'm going to attach them to 3 separate database services. And I chose 3 just because I wanted to show that we could do this a multiple number of times. It could easily be 1, it could be 10, it could be 20, it could be whatever we want it to be. And again, same command, docker compose up. And this one's going to take a little bit longer because obviously I'm creating 3 separate containers. Because of the networking that I have, the overlay, the way I have the networking done on Windows, it takes a little longer to create each one of the virtual network interfaces.
Is there a limit to the number of volumes I can have on a Nimble array?
There is technically, but it's so big, we haven't run into it.
But is it of the millions or tens of millions range, or is it of the several thousands?
To tell you the truth, I'd have to look that up specifically.
Yeah,
We've never even run into it. It's that many. So I'm switching, but if you write that down, I'll text with somebody real quick and get you a direct answer to that. But as you can see, one of the things that I'm doing is I'm switching back to the array, and all of my clones are done, and they were done instantaneously. They're all at 0 bytes because, again, these are 0 copy clones. So only writes or changes are what's tracked. And we're going to wait for this to finish. And now we do a Docker volume ls. We'll notice we have 6 new volumes, as well as the 2 from my original source clone. And if we do a listing of the running containers on this Docker host, we now have a total of 4 running containers, and they're all fully functional separate SQL Server instances, right? Right now I'm going to connect to all of them just to show you that they work. And it takes a few seconds to connect to the SQL Server instances after they come online. Typically, SQL takes anywhere from 10 to 15 seconds before it starts accepting connections. So we'll go ahead and connect to all 3 of them. And if we examine all 3 of our newly created clones, we compare it to that data set, that new data set that we had created within our original clone, you'll notice they're all the same, and that data set was updated. So we started with a production data set, we cloned it into a container, we manipulated it for our purposes, whatever those were, and then we went through and we created more clones of that. And we did that all using the Docker Volume API. You didn't see me have to go do any extra footwork. We just essentially use Docker Compose and our volume driver to do this. Okay. Again, these are not linked clones. So what I'm doing here is I'm creating, for example, on that 3rd container, I created another table, and it didn't affect the 2nd container tables or the 1st one, right? These are all fully independent. So now I'm going to do a little cleanup just to show you again the behavior of one of the options in our Docker driver configuration file, right? So I've detached the database instances, and there we go. And now I'm going to execute a Docker compose down. -v again says take down the container, also remove the volumes. This isn't anything specific to Nimble. This is just the way the Docker engine works. So this is all a native interface. And if I go and I look at the array where I'm going to refresh the view of this folder where those cloned volumes were, and you can see they're starting to come offline. You see one that's already offline, okay? 2 of them are already offline. Oh, goodness, I'm gonna have to not touch my machine. So there we go. Another refresh, and now you can see that all 6 of them are offline. that project. Remember, I was in that project directory. So all 3 of those containers that I created as part of that project are gone, and all 6 of the volumes are also gone. I'm now going to, and when I say gone, they're gone from Docker. They're offlined on the array, and that's because of the way I configured my Docker driver configuration file. I'm going to do the same thing for my source clone, docker compose-v. All right. And if we go back to the array, we see now that everything but the production instance, the production volumes themselves are offline. So all of my clones are offline. Why do this? Well, you may want to keep them around. If you're doing some sort of development workflow, you may want to be able to go back to a certain iteration, right? So you may want it there for historical purposes, archival purposes. The reasons are many, or you could configure the driver to delete them on removal. It's really up to how you configure each host. The reason why I got a 2 volumes failed to delete is because I like to click very little, so I selected all of the volumes, and you need to delete the clones before you delete the parent source. But you'll notice after I said OK to the error, those 2 source volumes were still clicked, and I'm too lazy to click again. So it was just easy for me to hit X. All right, any questions so far?
Pretty much like a true IT person is lazy. I don't care to click that button.
Yeah, that's right. So, but I always get a question about that, and people always ask me why. And it's like, well, because otherwise I would have had to click through 6, hit delete, then go back, click 2 more, then hit delete, where I could just say OK, then delete again. So, any questions before we move on to the next demo? So now we're going to switch back to Linux. And so now we're back on our Linux Docker host. And we're going to do the exact same workflow to a degree, not as involved, with a little bit of a difference on our Linux Docker host. And, you know, there's an important thing that we're going to key in here. Make sure this is running. That I want to bring up. And that is that I'm going to be taking a database that's running on Windows, right? I'm going to be cloning the volumes that back up that database, and I'm going to be importing them into my Linux Docker host, and I'm going to attach that database, bring it up and running on SQL Server on Linux, on a containerized SQL Server on Linux instance, right? So that's kind of a multi-platform data story. Right now, Microsoft's only way of migrating data between the two is to do a backup and restore. We're able to leverage our zero-copy clones to do it. So taking a look at a Docker Compose file for this workflow, again, I'm making use, so if you take a look at the driver options, which are right here, I'm making use of that import vol as clone. To the right of that is the name of the volume on the array. I'm also going to be using a couple more options. Since that production volume is in the prod SQL folder, which has no limits to either space or performance, I want to actually limit these clones, right? So just as a quick refresh, if we look at the folder that our production database is in, it has no limits. And I don't want my clone, for whatever purpose I'm bringing it up, to impact my environment, right? My production environment. So that's why I've made use of that limit IOPS and limit megabytes per second option. Okay. Again, I'm making use of the Microsoft SQL Server Linux image that's available on Docker Hub. And in this case, it's a different network. I'm using the overlay, the default overlay network for the Docker engine. I'm going to be connecting to port 1401. Okay. All of you will know how to do a Docker Compose up by the time these demos are done. So Docker Compose up, guess what? Our volume driver created the clones, imported it into the container, and now we're able to connect to that container. And just as a quick refresh, Docker volume ls, here are our clone volumes that have been imported into the Docker engine. And you can see here from a Docker PS that our container is up and running, listening on port 1401. So we're going to go ahead and connect to it. And we're going to attach the database. Now, there's 2 ways to do the automation of attachment. On the Windows side, they've included this attach DBS JSON string that you can use as part of your Docker Compose file. On the Linux side, they're working on it. They haven't gotten that done yet. But you can easily do what I'm doing here, which is essentially running a query. It's a very simple query as part of an entry point script in a Docker file. So you certainly don't have to do this manually. I just wanted to kind of show the manual process, and this is why I did it this way for the demo. But I've attached the database now. Production database running on SQL. Development database running on Linux. Now, why show this? I'm going to pause it real quick, or actually I'm going to keep talking to see where the video goes. Why show this? Right now, Windows containers is fairly new in the container ecosystem. So what are most people running? Linux containers, some form of Linux containers, right? So the reason why I show this is because Microsoft has made a very big deal to showcase their SQL Server on Linux platform. And in particular, they're very eager to tout that it is supported for enterprise operations as a container platform. Okay. What I did here on the second part, you remember I said I was going to do the same things I did in the previous demo. I'm just editing the database in our container to show you that they are not linked. It's fully functional, separate instance. I can write to it, I can delete from it, I can do whatever I want to do to it. And as you saw, I basically created a new table, deleted another table, and I'm going to now create a clone of that data set into a new container. Take a look at the Docker Compose YAML file. I'm going to be making use of the clone of option. To the right of that is the name of the volume as it is in Docker. So when we did the Docker volume ls, that's the name of the volume in Docker, and we're creating a clone of that. Again, I'm using the same Microsoft SQL Server Linux image that's available on Docker Hub. And at this point, I'm going to do a Docker Compose up, something you guys are all going to be very familiar with. And if we take a look at the array and do a refresh here, you'll notice we have all 4 cloned volumes, right? And if we take a look at this volume, one of the interesting things about it is it's got the IOPS limit set on it, even though in my Docker Compose file I didn't have those IOPS limits set. And the reason why is because our clones inherit the options of the parent. So my first clone, I created those limits. I had the IOPS and throughput limited. So when I created a clone of those cloned volumes, they inherited those settings. So I didn't need to put them in. Again, what I'm going to do here is I'm going to attach the database. I'm going to give it a different name this time so that you guys can tell that it's a different database. Right? I'm going to make sure that this is running on the right instance. I'm going to execute, refresh my database view, and woohoo, my database is there. And if we compare really quickly, just look at the tables, you'll notice it's an exact copy of the source database. Right? Now I've shown you that I can edit downstream. We can also edit upstream. So you can see I'm not going to pull any wool over your eyes. What I'm going to do is I'm going to edit the source database again, and then I'm going to refresh my clone, just to show you how easy that operation is when you leverage R0 copy clones in conjunction with our Docker volume drivers. Okay. So real quickly here, just for demo purposes, I'm going to delete a table in our source clone. Right. I'm going to go ahead and detach this database. Actually disconnect from the instance. And I'm already in the appropriate project directory. I'm going to do a Docker Compose down -B. That's going to take down the container, remove the volumes from Docker, also delete them on the array. Finish up. As you can see, they were removed from the array. And now we're just going to do a Docker Compose up. And now that this is complete, I'm going to connect back to that database engine. Right? I'm going to attach the database again. Just make sure that we're running the query on the appropriate instance. And after we do a refresh, you'll see that the changes that I made in my source are easily propagated to my clones. Right? Okay. In the interest of time, I'm actually going to move forward a little bit. I actually had another cleanup that I was going to do, right? But I'm going to move forward a little bit here to show you the last thing that we're going to do. As a demo. You heard Stacey talk about it briefly. This idea when you listen to anyone talk about containerization, inevitably you have these buzz phrases come up about updating your legacy applications, modernizing your applications, lift and shift, right? And all of these things can be kind of boiled down to something as simple as basically taking your legacy application and just moving it into containers. Or you could rewrite your legacy application as well as moving the data into containers. You could rewrite it so that it's more of a microservices architecture, right? And so what I'm going to be demoing here is kind of a minor lift and shift. So I'm going to take this BERT-DB2 database. Okay, this is going to make use of a different volume option that we haven't yet made use of in any of our demos. So we have this BERT-DB2 database, and what we're going to do is we're going to migrate this into a container, right? So first we need to detach it from the, let me move this so that the player goes away. We need to detach it from the SQL Server instance. Okay. And just for grins, because we spent so much time on Linux, I'm going to switch back to Windows. So I'm going to go back to Windows containers, although this could easily be done on the Linux container side. It's the same option. Both our plugins have the same options because we're leveraging the same API, right? After detaching the database, we do a quick refresh. You'll notice that database is gone. I'm already in the appropriate project directory. If we take a look at the Docker Compose file here, under the volume specification, you'll notice that the driver option that I'm using is the import vol option. So I'm not creating a clone here. I'm not creating a clone of a clone. I'm not creating a volume. What I'm doing here is I'm taking the volume as it is on the array after I've detached it, right, from my SQL instance. I'm importing it into Docker. I'm attaching it to a container. Then I'm going to bring that database up, and it's going to be available for application connectivity. So doing a Docker Compose up-d, which is again is detached, so it releases a terminal for me. At this point, if I do a Docker volume ls, I have my 2 Docker volumes, and these are just imported Docker volumes, and I have my instance or my container up and running, right? I'm going to go ahead and connect to this instance. And you'll see the database is there. Since I didn't change, in the attached DBS JSON string, I didn't change the name of the database, only the IP address, it becomes really easy to modify your application connection strings to hit the new container database. In this case, it's just going to point to either a new IP address or a new DNS name. But of course, the instance name still stays the database name still stays the same. So your connection string is mildly modified. And I'm just going to start running transactions against it to show you that it's ready to go for operations, right? And if we take a look at the array, we haven't done anything to the volumes. They're online. They're on the array. All we did was import them. It's not a clone. And if we look at the real-time statistics, you can see that we are churning against those volumes right now. Pretty soon you'll see a yellow line there. That yellow line, this is really neat. I just wanted to show this. on one of our previous demos, we had an orange line that went across the performance bar. Do you guys remember that? That's the orange line that tells you you're exceeding an IOPS limit at the volume level. These volumes don't have a specific IOPS limit set at that volume level. They have it set on the folder. So all the volumes in that folder can't exceed a limit of 1,000 IOPS or 100 megs. So what I did is I just increased the limits on the folder itself, which are inherited by all the volumes that do not have a specific QoS policy set, and you'll notice my orange lines go away, right? And that's it. It's kind of shows you some of the features that we have available to us with our Docker Volume plugin. And I did, the funny part is this took 30 minutes and I still didn't even finish showing you all of the features. For example, we didn't go over protection templates. So during Docker volume creation, one of the things that we can do is we could automatically assign those volumes to a protection template that has pre-configured snapshot or replication settings for data protection. Stacey, you want to close this out?
Sure. I just very quickly, I'll skip the summary since we're over time,
Yeah.
but wanted to, I think somebody asked whether or not this code is on GitHub. Oh, I should be standing over here. You're right. I don't actually think it's on GitHub. And correct me if I'm wrong. Everything you saw today is free to our customers, and it's available with an InfoSite login. We also have code on the Docker store that you can download.
When you say code, you mean everything I did from a demo purpose?
Oh, everything.
So everything I did from a demo purpose is not available. However, our Docker volume drivers are on Docker Hub, so that is freely available.
That is freely
let's
available.
Clarify the two questions.
Exactly.
I thought you were asking just about the drivers.
No.
Okay. If you wanted to know all about what I just did today, no, that's homegrown.
Okay.
But it's something that I'm happy to share. Yeah. I mean, it's
The demo or the drivers should be open source? Which one?
All
All
yeah,
of
so
it.
the drivers are out there.
The drivers are out there. They're not exactly open source, though. No. So they're free, but they're not open source. We do offer something that is open source. We have a Kubernetes Flex Volume driver that is on GitHub today, and I can tweet the URL where that is on GitHub if people are interested with the HP Tech Day hashtag. And what that does is anybody who has a Docker Volume driver can turn it into a Kubernetes volume driver instantly with our, open source thing. But our Docker volume drivers are currently not open source because they require a nimble array in order to function. And so, yes. Oh,
yes,
yeah.
you can
it's
download the
completely
driver. So you can download the drivers from InfoSite. You can also download, again, because they are Docker certified, they have to be available on Docker Hub. So you can also download them from Docker themselves. But yes, with an InfoSite ID, you have that. And then everything I did here is just basically leveraging the Microsoft. I have no Docker file. I made it as simple as possible for the purposes of this demo because I wanted to shine a light on our volume options, not on fancy orchestration, which is part of the value add of containers. But what I wanted to show here is what we bring to the table to that fancy orchestration.
If you wanted open source, the demos and all that, we'll talk about that. We'll
Yeah.
see.
I mean, I can definitely put everything I did out there. So.
Okay, we're gonna let's take a break.